Hi, in this video we are going to see about small scale fading parameters in mobile radio propagation. Fading is a phenomenon that occurs due to varying parameters and conditions of the channel during wireless propagation. Small scale fading refers to the rapid changes of the amplitude and phase over. It occurs in short period of time and also for a short distance. Small scale fading depends on the nature of the transmitted signal with respect to the characteristics of the channel. Factors influencing small scale fading. First one is multipath propagation. The presence of reflecting objects and scatters in the space between transmitter and receiver creates a constantly changing channel environment. It causes the signal at receiver to fade or destroy. Speed of mobile receiver. The relative motion between the transmitter and receiver results in a random frequency modulation due to different Doppler shifts on each of the multipath signal. Doppler shift may be positive or negative depending on direction of movement of mobile. Speed of surrounding objects. If the speed of surrounding objects is greater than mobile, the fading is dominated by those objects. If the surrounding objects are slower than the mobile. The transmission bandwidth. Depending on the relation between the signal bandwidth and the coherence bandwidth of the channel, the signal is either distorted or faded. If the signal bandwidth is greater than coherence bandwidth, it creates distortion. If the signal bandwidth is smaller than coherence bandwidth, it creates small scale fading. Multipath structure is very important for small scale fading. Several methods are used for calculating the small scale multipath. The first measurement is direct RF pulse system. Second one is spread spectrum sliding correlated channel surrounding. And the last one is frequency domain channel sounding. These techniques are also called as channel sounding techniques. This method helps us to determine the power delay profile directly. The objective of the direct RF pulse system is to find impulse response. A narrow pulse is used for channel sounding. At the receiver, the signal is amplified and detected using an envelope detector. After that, it is then stored on a high-speed digital oscilloscope. If the receiver is set on averaging mode, the local average power delay profile is obtained. The diagram for calculating the direct RF pulse system is shown in this figure. Delay, spread and coherence bandwidth. It describes the time dispersive nature of a channel in a local area. A received signal suffers spreading in time compared to the transmitted signal. Delay spread can range from a few hundred nanoseconds for indoor scenario up to some microseconds in urban areas. The maximum excess delay is defined as the time delay value after which the multipath energy falls to x dB below the maximum multipath energy. It is also called excess delay spread. Coherence bandwidth. The coherence bandwidth translates time dispersion into the language of the frequency domain. It specifies the frequency range over which a channel affects the signal spectrum nearly in the same way, causing an approximately constant attenuation and linear change in space. The RMS delay spread and coherence bandwidth are inversely proportional to each other. The coherence bandwidth, a range of frequencies over which the channel can be considered flat. It is a definition that depends on RMS delay spread. Two sinusoids with frequency separation greater than Bc are affected quite differently by the channel. Time dispersion parameters. It is determined from a power delay profile. The RMS delay spread is the square root of the second central moment of the power delay profile and is given in this equation. Doppler spread and coherence time. Delay spread and coherence bandwidth describes the time dispersive nature of the channel in a local area. They do not offer information about the time varying nature of the channel caused by relative motion of transmitter and receiver. Doppler spread and coherence time are parameters which describes the time varying nature of the channel in a small scale region. Time varying nature of channel caused either by relative motion between base station and mobile or by the motion of objects in channel are categorized by BD and TC. Doppler spread. Measure of spectral broadening caused by motion. To compute Doppler shift, Fd is needed. Doppler spread Bd is defined as the maximum Doppler shift, which is given by Fm equal to V by del lambda. If transmitted signal bandwidth is larger such that Bs is greater than Bd, then effects of Doppler spread are not important. So Doppler spread is only important for low data rate applications. Coherence time. Coherence time is the time duration over which the channel impulse response is essentially invariant. If the simple period of the baseband signal is greater than the coherence time, then the signal will distort, since channel will change during the transmission of the signal, and is given by this equation. Tc is approximately equal to 0.423 divided by Fm. Coherence time definition implies that two signals arriving with a time separation greater than Tc are affected differently by the channel. Assessment questions. Thank you.